All right, so number 8 reaches the height of this above the launch point 2.5 seconds later. Assume air resistance is negligible. What was the pebble's initial speed? And how much time did it take the pebble first reach a height of 16 meters above its launch point?
Looks like people didn't understand all of them, but I just know once that happened.
Excellent, thank you. All right, so what do we know the pebble has to do at the very top so that it can stop moving up and start moving down? It has to hit 0, it has to stop. So that's the first thing I would put in my Y. This is number 8. At the top, the stone stops. And you can even put in parentheses, that means B equals 0. Right, because that it has to stop at the top so it can turn around and come back down. Ooh, what else do we know about this stone the whole time? Okay, well, not the top, it's not moving. Constant acceleration. So it's in what we would call free fall. Well, that's the title of the section, right? So the acceleration, and what do we know about the acceleration? Well, we know it's constant. Which direction does the acceleration go? What do you mean by positive? No. Because it always goes down. It's always down. In free fall, the acceleration is always down. That's to keep in mind. And how big is it? You have to remember off the top of your head? It's little g, which is 9.80 meters per second squared. So when we say free fall, what we mean is accelerating down, no matter how it's moving. The free fall is accelerating down at little g, at 9.80 meters per second squared. So what's the stone doing on the way up? Is it speeding up, staying at a constant speed, or slowing down? On the way up. Okay. So, we've got this stone. It's here, it goes up, zoop, comes back down. We said up here it's stopped. As it moves up here, it's slowing down. As we go up here. And that's because we have this constant acceleration downwards. What's it doing on the other side as it falls down? It's getting faster or speeding up. So, we understand a lot here. And let's see, think about some other facts that they told us. They told us that it takes, it's 32 meters up there, and it takes 2.5 seconds to get there. So, putting in those other facts into my little diagram here, they tell me that this is 32 meters, and the time up, I'm going to actually write that down here, time up equals 2.5 seconds. If it takes 2.5 seconds to get up there, how long is it going to take to get down? 2.5 seconds. Oh, so that's also the time down. So how long after I shoot this stone up, better I make sure I run away? 5 seconds. All I can think of is that scenic grown-ups. What, arrow roulette? Yeah. Ooh, that could be a problem for this test, couldn't it? Ooh, that would be interesting. Time it on the video to see how fast it was shot up, by how long it took to come back down. We'll watch that little segment. Because the rest of it doesn't have much to it. Except it has Woodman's, where I worked at when I was in high school. In the show, so. Good. So now I've kind of forgotten. Let's go back to the problem. They want to know what was the pebble's initial speed after leaving the slingshot. So they want to know it started upwards here, and we'll call that V initial. They want to know what speed it started up with. Well, let's see. I know it went from that high speed down to 0 as it accelerated down. It slowed down to 0. It did that through 32 meters, but it also only took 2.5 seconds to do that. So if I look at my equations here, this one says I end up at this speed because I started this one and I accelerate for this amount of time. This one says I end up at this speed because I started at this speed and I accelerate for this distance, this displacement. Which one do you think we should go with? The one that's based on changing your speed because of time or changing your speed because of distance? We could actually do either one, right? Because we know the time and we know the distance. So, but let's grab the time one, because isn't the math a little bit easier? Yeah, there's none of those nasty squares. So let's grab this one. You don't like that sound? It's a camera shutter. And let's see. So this is part A. Should have labeled that. My V final. What's my speed right at the top? Oh, speed at the top we said was 0 meters per second, right? I just want to check one thing that I'm not going through. Okay, yep, I know. We don't know what speed it started with the velocity it started with. But which direction would it have to start? Which direction would that velocity have to be in? For the pebble to go up and then come back down. It would have to be upwards, yes? Right? If I shoot it down, it's not going to go up, right? Yeah, just checking. Which way do you want to call positive? Upwards or downwards? Upwards? Okay. So we're going to call upwards positive. So VI is going to be positive plus, now my acceleration's downward, so it has to be negative. And I know that it has the value of little g, so that's 9.80 meters per second squared. And it does that for 2.5 seconds. I love it when I get an equation that has all numbers and one variable. Because it's downward. And we said upwards is positive. So, I need to get VI by itself, so I'm going to bring this stuff over to the other side and have negative 9.80 meters per second squared times 2.5 seconds equals VI. And then I get VI equals, what's negative times negative? Hey, cool, I'm going to get a positive answer. Didn't I say VI should be positive? Yay! So I probably did it right then. And I get 24.5 meters per second. Let me check my handy-dandy answer key, unless someone already did. My handy-dandy answer key says yes. If you do this, sorry, I was just looking at something. If you do this with the, that's the correct answer. If you did this with using the 32 meters, you'd actually come up with a little bit larger answer. So if we rounded this to 2 sig pigs like the author was thinking, you'd have 25 meters per second, and that would agree either way you did it. But they were thinking 2 sig pigs when they gave the 32 meters and the 2.5 seconds. On to part B. In part B, they want to know how much time did it take for the pebble to first reach a height of 16 meters above the launch point. So they're saying at some point here, that's at 16 meters. And they want to know how long it took to go from the launch point to 16 meters. All right? So, yeah. From the bottom to the top, yes. 16 be more in the center?
Yeah.
Yes, but if I had drawn it in the center, I would have had to write over my slowing down. So I drew it higher up. I drew it higher up because I didn't want to draw over my own letters. Okay. So I want to know how long it takes to get to 16 meters. If I look at my equation sheet, the one that talks about I get to this place because I started someplace and I was moving and I'm accelerating is this one right here, our top main one. Whenever it says, getting someplace. So that's the one I'm going to grab. I was waiting for you, sir. And so let's see. I'm going to get to 16 meters. I'm going to start at 0 meters. My initial velocity that I'm starting at, 24.5 meters per second. I don't know what time I'm going to get there. I do know that I'm accelerating downwards at 9.80 meters per second squared. But I don't know my timing yet. Oh, that looks like a quadratic equation, doesn't it? So, now you guys you've learned techniques in math to solve those, right? Yes. You want to know another way to solve them? Okay. Here's another way to solve them. If you jaunt it out to our website, it's amazing how many times we go to this website. And you go down here, there's a nice thing that says nice equation solver. Wolfram Alpha. Okay? You can also get this on your phones. Don't do that, just go to the website. And if I put in the equation 16 equals, I need to go back and look. 16 equals, can I forget about the 0? Right? 24.5 times t. Here, I'll make it bigger. Times t minus 0.5 times 9 negative, sorry, negative 9.8 times t squared. All I've done is typed in my equation. I hit equals. And it tells me that my answers are either negative 5.58 seconds or 0.584 seconds. Well, because math isn't as smart as physics. Math says on that equation, it hits that point twice. Once in negative time and once in positive time. Which one do you think we care about? Positive time. You can't have negative time. So it's the 0.584. Right, because acceleration is direction. How do you move backwards in time? You can't. That's why you can't have negative time. Huh? We'll save it for the spring of why never. And if we did it like using their numbers, the only difference would be this thing, change that to 25. We would get we get 0.575. All right. Number 3. Top of a cliff, person throws the stone straight downwards. The initial speed of the stone just after leaving the person's hand is 9.1 meters a second. So what do we know automatically the stone is doing as soon as it leaves his hand? So therefore it's in free fall, it's accelerating downwards. So stone in free fall. So A is down and 9.80 meters per second squared. We haven't defined negative and positive yet, but most of us understand up and down. That's why I use down. Could I define down as positive? Could I define down as blue? Yeah, they're the same. Right? So, down itself is the title, but I tend to use it because it's not, don't assume down is negative. It can mess you up. So what's the acceleration of the stone while it moves downwards? 9.80, in which direction? No, let's go back, let's look at our y. Which direction is the acceleration? Down. You know, are these jiving with your stuff so far that you did? Not update your work. Is the stone's speed increasing or decreasing? You said increasing? I would agree with increasing. Because, let's see. So the velocity and acceleration are in the same direction, therefore speeding up. Remember, to speed up, it means your velocity and your acceleration are in the same direction. Slow down means they're in opposite directions. So the stone is speeding up because it was thrown down and it's accelerating down. After 4.7 seconds, how far beneath the top of the cliff is the stone? Just give the distance fallen, not its magnitude. Yes. Magnitude is size, numerical value. Well, what they're saying is, we don't want to tell you, so which way are we going to define positive? Oh, okay. That would mean that if we were to calculate the displacement of the stone, it would be negative, right? But the magnitude of it, how big that displacement is, would always be positive, because the negative is just indicating downwards. or at the size of the measurement. So, like, let's say I find an answer here that's negative 15 meters, which means it's moved downwards, the negative, at 15 meters. The magnitude of that is 15 meters. Yes. Think of it like absolute value. It's how big the vector is.
Oh, so
Acceleration is a vector, so how big the acceleration is its magnitude, and then in what direction. Like when we wrote the y here, we wrote that the acceleration was this big. That's its magnitude, 9.80 meters per second squared. Its direction is down. So the vector that is acceleration is down at 9.80 meters per second squared. The magnitude is just 9.80 meters per second squared. Scalars and vectors, back to the beginning of chapter 2. And we're going to spend a lot more time on those in the next section, actually. So, we got plenty of time. So we got the stone here. It has an initial speed of 9.1 meters per second. Downwards. It's going to fall some distance t. We know it's accelerating down at 9.80 meters per second squared. Just for the fun of it, do you guys mind if I call down positive? Why is it going to confuse you? Just stand on your head. Imagine you live in Australia. All right? Down is positive. Well, because then I won't have to deal with all these numbers, all these negative numbers. And let's see, they want to know after 4.47 seconds, so the time it travels for equals 0.47 seconds. So, I want to know how far it's gone, given all these conditions. Oh. I have an equation that talks a lot about where something is because of all of its initial start. And that's this first one, right? Yeah? Good. Glad to see you guys are getting this. Makes me more confident. So I picked that one. And I substitute in, I want to know where it started. I'm going to be lazy and call where it began at 0 meters, plus its initial velocity was 9.1 meters per second. It traveled for 0.47 seconds. 1/2. It was accelerating down at 9.80 meters per second squared for 0.47 seconds squared. Yay, all numbers on one side and a variable on the other. So now I can use arithmetic, right? Take 9.1 times 0.47. Add to that 0.5 times 9.8 times 0.47 squared. And I get D is 5.36 meters.